I hope everybody had a chance to get up and stretch their legs over the past few minutes. If you're like me, maybe you're working from home. I found that I probably sit far too much these past few weeks, so it's good to get up and move around. So we'll get going. And as Bob already mentioned, I work for Farm Credit Services of America here out of Omaha. I lead our solutions architecture team there. Farm Credit Services of America, we are a financial lending institution, kind of like a bank, but we're not a bank. We provide loans and services and things like that, financial services to farmers, ranchers, basically those folks that are responsible for growing, raising food, and getting it to ultimately to your table. So that's what we do here in Omaha. And we are one of the sponsors of today's event, so happy to be part of this. You can see my contact information there. I'll post the link to these slides also out in the comments once I'm through talking here as well. So just real quick for setting the kind of the stage here, what is DevOps? I'm going to use a definition that Donovan Brown, if you're familiar with him from Microsoft, he tends to use this definition, that DevOps is the union of people, process, and products to enable a continuous delivery of value to your end users. If you can't get it to your end users, it's not very valuable. So you want to do that as efficiently as possible. When I'm talking about Azure DevOps today, I'm really speaking more to the products aspect of it, which also enables the process, and then, of course, the people piece of DevOps. So you can kind of see on the right there, Azure DevOps has a little bit of a storied history. It's been rebranded several times within Microsoft. Started as a Team Foundation server, as an on-prem product only. They ultimately provided a Team Foundation service, which was a cloud version of the Team Foundation server. Rebranded that to Visual Studio Online. Also, it was Visual Studio Team Services, and more recently is Azure DevOps. And so you can think of Azure as being the cloud with built-in DevOps tooling. Obviously, this is Global Azure Day, so everything kind of ties back to Azure. When we're talking about Azure DevOps, we're specifically talking about some of the delivery capabilities that is part of Azure. And we'll talk about each of those specifically. But hey, let's clear up the A word first. This probably isn't as big of an issue as it was when I first started doing this talk about a year ago. After Microsoft rebranded to Azure DevOps from Visual Studio Team Services, Visual Studio Online, so on. There was a little confusion at first. I found with various customers and folks out in the world. For example, does Azure DevOps require an Azure subscription? The answer is no, it does not require an Azure subscription. As you'll see later in the presentation toward the end when we talk about pricing, you can use Azure DevOps to a certain extent completely for free. Azure subscriptions are not required for any aspect of that. Will Azure DevOps work with non-Microsoft technologies? And when you're thinking of Java, iOS, things like that, answer is yes. It's for the most part very agnostic of the languages and tools that you're building for. Will Azure DevOps work with AWS or GCP or Google cloud provider? Answer is a simple yes. It will work for those as well as any cloud provider for that matter. And what about open source? And yeah, again, yes. So Azure DevOps it's there to work pretty much with anything that you might be working with on a day-to-day basis. Okay, so Azure DevOps is comprised of 5 primary services: Azure Boards, Azure Repos, Azure Pipelines, Azure Artifacts, and Azure Test Plans. Those are the 5 main components of Azure DevOps, and we're going to kind of walk through each of these at a relatively high level. We don't really have a lot of time to get into any of these in any super in-depth way, but we'll at least cover each one of these. And there's a few other things that Azure DevOps has outside of these 5 primary services. We'll touch on those lightly as well toward the end. And I didn't say anything about questions, but please add any questions to the chat page, and we'll get to those later and today. So first off, we'll start off with Azure Boards. So if you've ever used, like Trello or LeanKit or, maybe like Microsoft Planner, you're familiar with electronic Kanban style boards. That's what Azure Boards essentially is. That's what it looks like, but it's a whole lot more than that. So I've got a kind of an image of a board here in the upper right corner of my screen. And so you can kind of see, yep, there's a bunch of cards and a bunch of lanes. Each of those cards essentially represent a work item, as it's called in Azure DevOps. And that work item might be a user story, for example, a user requirement. Sometimes you might call those product backlog items or PBIs, whatever your terminology is for whatever methodology you're making use of. It's essentially what those are. And so boards allow you to connect ideas to releases. And that's one of the really powerful features within Azure DevOps, since it does provide an end-to-end solution. You could start with your idea of one of these work items, one of these cards on the board. Then as it goes through, for example, code commits into a repo, automated tests, automated builds, and then ultimately an automated deployment, you're able to trace from one end to the other that whole spectrum to see exactly which requirement led to which code, which led to which deployment. So very, very powerful capability. There are some Scrum features built in that helps you, for example, with your stand-ups, planning your sprints, and so on and so forth. And you'll see some of that here in just a moment. Integrates with GitHub commits and pull requests, and provide some insights into your project status and health. Again, you see that board in the example there. You can look pretty quickly and see what things are active, what things are being staged, what's deployed, and so on and so forth. The boards are based on process templates, and you can use out-of-the-box templates or create your own custom templates in Azure DevOps. Essentially, these process templates define the fields that show up inside of these work items or these cards, the types of information you want to record and track with these various cards. Also includes rules for controlling when a card, for example, can move from one state to another, or even back to a previous state. It's very easy to tweak the board to add columns, remove columns. And you can add swim lanes, which is kind of like a horizontal row as well. For example, like an expedite row. You can configure rules, change background colors, all kinds of neat little gee-whiz stuff that just kind of makes it nice to work with. And you can tie your work items to source code, and that's part of that traceability I was talking about a moment ago. Source code builds, deployments. Matter of fact, you can, through something called branch policies, which we'll see here in a little bit, you can even require that work items be tied to your code commits. So that said, let's go see what this kind of looks like in real life. So I've got 2 or 3 demo projects I'll be using today. I'll just kind of be bouncing between the various ones, just showing off a few things. But immediately over here on the left, once you're in Azure DevOps, you'll kind of see those same 5 services I mentioned earlier, artifacts, test plans, pipelines, repos, boards. I'll get up to this overview toward the end, but I'm going to click on the boards tab for the moment. As soon as I do that, you'll notice there's some sub-tabs on here: work items, boards, backlog, sprints, queries. We'll go through each of those. So work items. So work items is really what those cards on the board are visualizing. That's what they visually represent, are work items. And there's different types of work items in Azure DevOps. And again, this is based on the process template that you choose. This one, for example, you can tell by the different icons here. Like, for example, this one's a PBI or product backlog item. This one's a task. This one's an epic. This one's a bug. And, there's other types as well, like features and so on. So if I open up this PBI, you'll see the details that are in there. We have a description. We have some acceptance criteria. It's not filled out. You can have discussions. These discussions are threaded in the order that the conversation happens. You can have other details such as priority and so forth. And then over here on the right, we see some relationships. For example, this PBI has a parent. It belongs to this particular feature. But this PBI also has 3 child tasks. And you'll see that visually represented here in a moment. But all of these fields that are on here are defined by that process template. So it's very, very customizable. So that's essentially what a work item in its raw state looks like. And again, you can see them all here along with various columns and attributes about that work item listed out. And those are all customizable as well as what you're displaying on the screen. Clicking the boards, this is probably the more interesting aspect of it. This is the visualization of those work items. So for example, these cards can be moved around and drag and drop. I mentioned earlier, one of these, or actually several of them, have subtasks. So this PBI For example, I can click on that and expand that. It has 5 subtasks that go along with it. So there's one that says add new columns. Maybe as a developer, I've actually completed that task. So I can go ahead and check it, and it basically changes the state of that task to being complete. And then once all of these are complete, I'll just click them all for now, then I can say, okay, this card is done. It's ready to go over to this done column here. And I should have pointed that out. Notice the columns we have new, approved, build and test, and deploy. This build and test one is subdivided into doing and done. You can do that to any of these inside columns if you'd like to do that. Again, it just kind of depends on what your methodology is. So it makes it very easy to move cards around, quickly get it at a glance, kind of see the state of work in the current sprint, or however you have it set up. There's some neat things in here too on filtering. And this live updates, for example, what that is, if someone else is signed into the same project on the same board, on a different computer, maybe even in another office, as they're moving cards around, you'll see that in real time on this board. I'm going to go into settings real quick as well, just to show, for example, you can add new columns in here. You can rename columns. Maybe I don't want it called new. Maybe I want to call this backlog as an example. You can do some neat things like I'll play with tag colors. Maybe I want anywhere that has a card with the admin tag on it, I want that tag to show up with a background of yellow. And there's other customizations in there as well. I won't go through them all because we just don't have the time, but go ahead and save that. Notice now my admin tags all have a background of yellow. This new column is renamed to be backlog as an example. And there's other colors. You can change the background colors of the cards themselves. So for example, I'll show another real quick one through styles. So we'll have a style for bugs, and maybe we want this one to be red. And we're going to say, we find work item type. Here we go. Work item type is equal to bug. So basically we're saying if it's bug, let's change the card color to red. So now, for example, the bugs really stand out. So you can do some neat things like that with the boards. There's some simple analytics on here if you want to view a couple reports. Velocity, for example, you can kind of see that based on what sprint we're in sprint 2 right now, that we have 8 essentially points of effort, story points, if you want to call it that, planned, how many is completed, and so on and so forth. Let's jump into backlogs. Backlogs, this is a really, really cool feature for helping to plan out a sprint or even multiple sprints. You notice on the left, I have my backlog essentially of work items. And over here on the right, I've got a planning area that has my defined sprints. I've got sprints 2 through 6 defined here, and you can define more sprints than that. That's just what's defined at the moment. And you can see that sprint 2, which is our current sprint, has 135 units, points, whatever you want to call those as a team of planned effort. Sprint 3 has 72, 56 for 4, so on and so forth. So for example, let's say this card here, which has a effort of 15, I want to be in sprint 3. I can just drag it into sprint 3, and notice its planned effort went up by 15 points. So it makes it very, very easy to drag cards into sprints and plan ahead. And if you're wondering, well, how do I know when I'm getting full? One of the cool features you can turn on here as well is something called forecasting. If you turn that on, you'll see forecasting lines show up. And then based on however you have your team capacity set up, which you can do under the sprints tab, team capacity set up, it'll start forecasting when it feels like, okay, sprint 3 is full with this PBI and these 2 tasks. This sprint 4 is full with this PBI, and so on and so forth. So it makes it pretty easy to kind of see, how much you're planning and if you start over planning. So really neat feature. Go into sprints. So in the sprints tab, we get a different view of the board. This is called the task board. And so this one's essentially kind of pivoted, if you will. If I collapse all of these, you notice these are all PBIs. So as a developer, I might spend more time in this board than other boards. So for example, I might be in here, I'm working on this PBI, I pick up this task, I move it in progress, and then ultimately I finish it and I move it to done, and then that's going to mark that task as completed. So this is a nice view for developers to easily move just task by task what they're working on. I mentioned capacity a moment ago. You can define and set up your team capacity in here. Like if I was going to have a set of days off next week, maybe I'm going to be off Monday through Wednesday as an example. Okay, I'm going to have 3 days off. During a typical day, maybe I can have 4 hours for unassigned work and 4 hours for development work. You can slice and dice this however you want, but really, really good way of setting up the capacity for your team if you get into that level of detail on your sprint plans. Really beneficial if you have larger teams. And I will not save that. So in queries, so we've seen all, excuse me, a lot of the work items listed out, and you can kind of find those on the boards, or you can kind of scroll through and find them, but there might be times where you want to query and find certain work items. So a couple of the queries saved here, for example, is work items assigned to me. So if I click on that, it's going to run the query, show, hey, all of these work items are assigned to me. So it looks like I've been busy or I will be busy. Maybe followed work items. These are work items I follow. I'm not following any right now. But maybe I want to create a new query. So you can easily create queries inside of Azure DevOps. Let's say I wanted to see all new bugs. So I can say work item type of bug, and let's say the state is equal to new. And you can continue to add as many fields and clauses as you want on this. And let's just go run the query. And so we've got 5 new bugs down here in that new state. And if I want to, I can save that query. I can say new bugs, and I can either save this in my queries, which is only seen by me, or I can save it into shared queries, which means anybody that has access to this particular team in Azure DevOps can see it. So now I can run that query anytime I want. So if I go out to shared queries, I'll see my query show up, click on it, and I'll see, yep, 5 new bugs. So very easy to create queries inside of Azure DevOps or work items. Those can be used also in charts. So we'll do a quick chart here. So a new bugs chart, and I don't know, maybe we just do, well, this probably isn't a very interesting one because it's only new bugs. But let's say assigned to won't really be to anyone yet, probably. Yeah, this is going to be a boring chart because everything is new. But you can get pretty creative with these charts. These charts can also be then added to dashboards, which you'll see here at the end as well. So that's a really quick high level of look at the boards. Bounce back. I make sure I keep track of time here because I will run out of time very easily in this talk. Azure Repos. So this is where essentially all your source code and artifacts live for things that you're building. You know, if you're writing C# code, obviously it's your C# code, Swift, so on and so forth. Azure DevOps provides Git-based repos as well as TFVC, or Team Foundation Version Control repos. TFVC is essentially the original version control system that Team Foundation Server provided. It's a centralized version control system. Still there in Azure DevOps, you can still use TFVC today. Although Azure DevOps probably sees more action today on the Git side of things, on the decentralized version control, than they do on TFVC. That seems to be where the world is moving to. It does support code reviews via branch pull requests. You can create branch policies and build validation and things like that, which is actually pretty cool. The branch policies, for example, won't allow certain branches to be merged unless certain conditions are met. It is an easy migration path to and from GitHub. It's just Git repos, so Git repos move pretty easily. Very scalable, supports PRs, granular security control, works with any language, and works with multiple development workflows. Git flow, trunk-based development. There's myriad workflows out there. Yeah, lots more. Let's take a look. So I'm just going to go down into the Repos tab. And initially what you first see is kind of like a folder/file structure of whatever your project is. And I'm using a sample project here called Smart Hotel 360. It's a web-based project. I believe it's running on .NET Core. And you can see, if I click on like the program CS, pretty basic, but you can see that the contents of the file show up to the right. If it's a markdown file, for example, it'll give you a preview mode of what's in that markdown. You can view the history on any of these files. You can, compare versions. We have the blame feature, which is kind of inherent to Git. This is kind of a boring one because there's only one person in the blame history there. Other files probably have more interesting blames, but not these. If I go to commits, this is essentially all the commits that have been committed into this repo. You can kind of see the commit graph down on the left. What you'll see inside of all of these repos tabs is, for the most part, it's just different views on the same data. So whereas this is all the commits, there's also a pushes view, which is essentially the pushes up to your repo. So one push, for example, might have a whole lot of commits in it. Things get a little more interesting in the branches. So I can see my branches, all branches, stale branches. In this case, mine and all are the same set. So you can see we've got a feature branch here, dev, our master branch, which is currently set as the compare branch. And what that's getting at is over here, we have this behind and ahead. So our dev branch, we can see, for example, is 8 behind and 0 ahead of master as far as the commits are concerned. And you can change this compare branch to any of these just by clicking on the little ellipsis over here and setting as compare branch. Yeah, I think I just changed my branch. Yep. Go back to master. Tags are just get tags. You can basically associate them with commits or whatever. And then pull requests. So this is probably the most highly utilized feature within a Git-based system. And if you're not familiar with pull requests are essentially a way of, after you've branched off some code, made your changes, and you want to get those changes merged back into another branch, say, for example, the master branch. You create a pull request, which then goes through a workflow process where someone or multiple people have to review your changes and then ultimately accept those changes so they can be merged back into that master branch. So let's click on this one. It says added packages, for example. So if I click on this PR or this pull request, and we'll see down here that someone's updated the package JSON file, which basically just means they've added an NPM package into the project. We can see that this new package, this bot framework web chat package has been added in. You can tell I was playing around yesterday. I'm like, yeah, bad idea. I don't know. Maybe, oh wait, never mind. Great idea. So yep, this is a good idea. But if I'm good with it, one of the approvers, I can come up here and approve it. I can also approve with suggestions, saying, yeah, okay, this is good, but you might consider this the next time. Wait for author, you can reject it. Then you can actually complete the pull request, which will then allow it to go ahead and be merged. There's also a neat feature in Azure DevOps called set autocomplete. And if you do set autocomplete, it's basically the same thing as completing the PR to allow the merge request, but the merge won't actually happen until all branch policies have been satisfied. Any of the conditions for branch policies have been satisfied. So for example, if there's not a work item associated with this particular set of commits, but there's a branch policy requiring those, well, then the PR won't be completed until that work item gets associated. So if I go into project settings real quick, go to cross repo policies, I can show you what that kind of looks like when you add a branch policy. So go ahead and create. So here's the types of things you can do. You can require a minimum number of reviewers. Maybe you want minimum of 2, and then you can set some conditions on those reviewers as well. You can check for linked work items. This is what I was mentioning just a second ago. Maybe you want to require a work item to be attached to that pull request. Well, you can require it, or you can set it as optional. If you set it as an optional, they don't have it. Well, they'll get a warning, but it won't stop it from going through. But if it's required, it will require it. It won't go through. Check for comment resolution. Just basically making sure, hey, we've got comments on this. Limit merge types. If there's certain things you don't want to allow, for example, maybe you don't want to allow squash merges, you can turn that off. And there's some other types of things you can do in here around build validation and so on and so forth. But the cool part is, get back where I was here. The cool part is that you can control those PRs at that level, so it's essentially automated, so people can't merge things in a state in which you don't want them to merge. And I stress that work item linking capability quite a bit with anyone I talk with, again, because of that traceability feature inside of Azure DevOps. If you don't have those work items from the very beginning linked, then that's one piece of that chain that'll be missing when it comes to traceability. All right, Azure pipelines. This is probably the most popular aspect of Azure DevOps. It's probably used, just my own assumption, it's probably used more than any other feature in Azure DevOps. And that's partially because Azure pipelines can be used from GitHub, for example, so you don't have to be in Azure DevOps to make use of pipelines. But I know it gets used a ton. So Azure pipelines is essentially built or split into two primary purposes. One is to build whatever it is you're creating, so it's to do the compilation and tests and things like that. And then the second real feature is essentially those deployments, the releases. So that's kind of how it's split up. And there was a time where builds and deployments were two very distinct things in Azure DevOps. They've since been merged essentially into a pipelines feature, so the lines have been blurred pretty good. I think it's all for the better, but when you're talking pipelines, you're really talking builds and deployments. Supports any language, any platform, any cloud. And by language here, we're really referring to, we don't care if it's Java, C#, Swift, Kotlin, it can build it all. Has native support for containers, Kubernetes, considered to be best in class for open source. You can deploy to on-prem, as in your own private data center. You can deploy to any cloud or hybrid of cloud and on-prem. Have staged environment releases, for example, going from the development to a QA to production, so on and so forth, whatever your environments look like. Where I work at FCS America, we have 4 environments that we go through to get to prod. And you can have pre and post deployment approval gates, which are pretty sweet, and we'll see those here in a moment as well. So the pipelines are really great, especially if you have projects that span platforms. If you happen to build systems that are going to run on Windows, Linux, and Mac, or some combination of those, it's pretty sweet because you can have a single tool that will work for every one of those. So you don't have to have different build tools for your iOS apps versus your Android apps, for example. You can do it all through Azure DevOps. Natively integrates with GitHub as well as Azure Repos. I already mentioned Kubernetes. There's 2 ways you can build and create these pipeline definitions. Traditionally, it's used kind of this drag and drop UI where you're dragging build task or deployment task into your pipeline definition. More recently, they've introduced the ability to do this with code or via YAML. The nice thing about doing it with YAML is that you can then branch your pipeline definitions with your code, and that is kind of the default mode now. And you can still do it with the drag and drop UI, but by default, it'll do it with YAML. What I'll be showing here in a second is still using the drag and drop version. There's still some parity yet to be gained with the YAML side. It's getting really close, but it's not 100% full parity yet with the original drag and drop when it comes to both builds and deployments. Let's take a quick look at this. I'm going to switch to a different project real quick and go down to pipelines, making sure I'm paying attention to time. So when I click on pipelines, I see recently run pipelines. If I click on all, I'll see all my pipelines. And in this particular project, I only have the one pipeline, especially for builds. If I click on runs, we'll see that this one's been ran a couple times. Matter of fact, I'll go ahead and drill into one of these. So if I click on one of these runs that's executed, this one was ran earlier today. Took 7.5 minutes to run. Had some artifacts published. The job actually succeeded. There was success. There were some warnings, no test results found matching this particular pattern. So no test results were actually published, but that didn't cause the build to fail. It just caused a warning. If I drill into this, we can actually see all the various build steps that were part of this build. And if you want to click on these, you can see the logs that go along with each one of these, so you can get pretty detailed as to what's going on there, which is really good, especially if you're trying to debug something that didn't succeed. So go ahead and back up. And to see what one of these looks like when you edit it, you'll see what I mean by the drag and drop type UI. So this is what the UI editor looks like for a build, kind of, I'll call it old school, the legacy version. We kind of have our pipeline starting up here. This get sources step basically says, hey, where are we getting our source code from for this particular build? We're getting it from an Azure Repos Git repo. You can see that it supports other types of version control systems as well. And then it gets into the actual agent jobs, and there's only one agent job defined for this one that has multiple build steps. So the first step, for example, is running this NuGet restore. And if you click on a build task over here on the left, you'll see the parameters associated with it over here on the right. And you can add new build steps in here anywhere along the way. Just click on this plus sign, and then you'll get the list of all of the capabilities over here on the right. And there's, I don't know, hundreds, thousands, I don't know how many there are. There are a lot of them. You know, maybe you want to do something with an Azure function, you know, do an Azure file copy or whatever, you know, interact with Azure Key Vault. There's build tasks for just about everything you can imagine. And if it's not there, you can create your own and upload those into the marketplace and then make use of them. So basically, you just build out your list of tasks however you want your build to work, get your parameters all set. These can be reordered pretty easily. And then you save it and execute it. Now, I mentioned the YAML. I'm not going to go build a YAML build definition right now. That editor doesn't look like this one so much because it's all text-based, being YAML, of course. It does give you a list of tasks that you can use to quickly bring in the YAML code, but there's no two-way synchronization, if you will. There's no two-way capability. You can't go from, like, say, for example, this view into YAML and from YAML back into this view. That does not exist. What you can do, though, is maybe you like the way you've got this publish task set up in this build and you want to look at its YAML. You can do that, copy that, and paste it into a YAML build definition. And so you can kind of save yourself a little bit of headache there if you've already got it configured exactly the way you want it. You copy it out of one, paste it into another. But again, there's no two-way synchronization. You can't go from one to the other and back. That's kind of what a build looks like. And then you can see things up here. There's other parts of the build, and you can have variables that are utilized within the build. And those variables can be public or secret, meaning you can click this little padlock over here and basically hide it, so only the build system has access to it. Triggers are for example, setting up scheduled builds. I want it to run at 4 a.m. every day except weekends, or maybe I want to set up a CI build, so every time something's committed, you can do rolling CI builds, so on and so forth. A few other options that you can have in here, like status badges are kind of cool if you want to post those into like a dashboard or a markdown page or something like that, just to show the status, the most recent status of a build as an example. You can set retention on your builds. Basically what that means is keep your builds for maybe the last 30 runs or last 30 days or whatever you want to set your retention to. You can also set them to be retained indefinitely so they don't go away. And then history, and this is pretty basic example, so I'm the only one in history. Moving along, environments. There's no environments defined here, but environments is where you can set up sets of resources, for example, maybe some production cluster machines and things like that. And so releases, so this is the other side of pipelines. So this is when you actually get to where you want to release and deploy the artifacts that were generated by a build within a pipeline. And you can see there have been 4 releases defined or executed here. All attempting to go to dev, they have all failed. And we'll look and see why it is. So I'll drill into one of these. You can see, yep, this one failed. If I click into that, you'll find out quickly, okay, error, task failed while initializing, input required, connected service name. This is part of the Azure deployment step. And so the reason that failed is because I haven't actually set these up and configured them with any kind of Azure subscription. So if I go in to edit this, if I click on that Azure deployment step we saw a moment ago, you'll notice like Azure subscription is not filled out. So I don't have this configured to actually deploy to Azure, primarily because for this demo I don't really need it, because I'm just kind of showing that the capabilities there and what it looks like. But you'll notice that this UI, this user interface, is pretty much identical to the build definition interface we saw earlier. It works and acts the same way. You can add all kinds of tasks. It's basically the same sets of tasks we saw earlier. You can drag those into your deployment definition or your release definition, and it'll execute just like it would if it was a build. Going back to releases, we can see, yep, there's those deployments. They've all failed. If I go into analytics, nothing crazy there because we don't have any tests actually running. I'm going to drill back into one of these again because I do want to show the excuse me, the pre and post deployment steps. So when you're setting up your stages and everything in here, so say for example before, let's jump to production. Let's say before production runs, I want a pre-deployment step. I click on this, and then you can define different types of things in here, different gates or whatever that you want to occur before it's allowed to pass this particular step. So you might have, like, I'll say a schedule. I don't know, maybe you want this schedule to release at a certain time, so you can set that up. Maybe you want to have an approval. So this is going to prod. So maybe I have to manually approve this within, let's say, 30 minutes for this before it will actually go to prod. So you can set up various things in here that really give you a relatively fine level control of what's allowed to actually move from one stage to the next. Likewise, there's post-deployment steps as well. And some of these gates, you might want to delay for 5 minutes before something happens. So let's say something gets deployed. We wait a few minutes for things to kind of catch up. And then maybe you're going to invoke an Azure function as an example to kind of, maybe it's a smoke test or who knows what it is, just to make sure things are going okay. So you can set those types of things up. You can have an auto redeploy trigger. So say, for example, the deployment fails on this production push. Well, then you want it to redeploy the last successful deployment. So you can kind of automate that rolling back if your deployment actually fails. And I'm doing this on the production environment or production stage, but these are all available for any stage that you define. So pretty powerful feature within your releases. Libraries where you can set up various variables and things that can be shared across pipelines, just like task groups allow you to kind of group sets of build and deployment tasks that can be shared. And then finally, deployment groups is where you can set up a group of machines that you might want to deploy to in parallel, like maybe a production cluster or something like that. XAML, this is a deprecated feature that's like the really old legacy. So YAML's the current build feature set. Prior to that is the drag and drop UI I was demoing, and prior to that was a XAML set that is no longer available except for like legacy apps that still had it, and I think it's even that's going to stop working at some point. I'm not sure when. Okay, I'm down to 5 minutes, so let's cruise through this really quick. Artifacts allow you to share code. So when you think about, like, for example, npm packages, NuGet packages, and things like that, that's what this is. It also allows you to aggregate public registries as well as internal teams. And where that's important, for example, if you think about one of your applications is making use of an npm package from a public registry, a developer decides, I'm bored with this, and he removes that package from the public npm registry. Your application no longer builds because it can't pull it down. Using the artifacts capabilities within Azure DevOps, those all get cached. So even if someone pulls it from the public registry, you still have it in Azure DevOps, so your builds on applications will continue to build as normal. So we'll take a really quick look at that. So here I'm looking at artifacts, and this is actually the artifacts store for where I work, because it was just a quick and easy one to look at. There's a whole bunch of Angular-based npm packages in here. We build most everything on Angular these days. You can kind of see the download rates over here. Some of these are very low, a few hundred. Some are getting higher, multiple thousands. There's also, if I start filtering out, for example, by FCSA, we'll start seeing some NuGet packages in here as well. These are all custom NuGet packages that we've built, that we've published internally. So these aren't even out in public registries anywhere, whereas these NP ones, these ones are, well, I'm filtering by FCSA, so these are also internal. But when I get rid of the filter, these are all publicly available npm packages, but they're being cached. So if this particular version 9.1.1, was removed from the public registry, we'd still be able to make use of it because it's cached. So that's a great feature. Okay, Azure Test Plans, I'm just going to speak to that one. I'm running short on time. Basically, Azure Test Plans, what it does is it allows you to set up a set of test suites and test cases that you can manually run through using a web-based test executor. And essentially it walks you through and says, okay, perform this step, and this is what the expected action is. And if the action is successful, you mark it as passing. Otherwise, you mark it as failing. You can create a bug right there in the test tool itself. If it fails, you can do screenshots. You can include information for reproducing the issue. And essentially, it just gives you a little more traceability across your application from a testing point of view. And looks like we're going to skip the demo. And here's kind of the results of what some test runs might look like at the end. This is kind of a more of a fancy one. They wouldn't all look like this, but again, pretty neat. So real quick, some other stuff. I mentioned this a second ago. I'd come back to it. If I can go back up here into overview, I think I can do this in 2 minutes or less here. You get some basic information about the project, boards, work items, and things like that. You can create dashboards in Azure DevOps. This one's very, very busy. It's really meant to be kind of like demo eye candy, if you will, just to show that, yes, you can do all kinds of neat widgets, graphs, markdown files, so on and so forth. You can create more than one dashboard as well. Analytics views gives you a way to tie Power BI into data inside Azure DevOps. And then Wiki is exactly what it sounds like. You can create wikis. Okay, I got about 3 slides left I'm going to plow through. So GitHub was acquired by Microsoft nearly a couple years ago now. I mentioned this mainly because they're doing a lot of work to make Azure DevOps work more seamlessly with GitHub repos. So that's definitely a space worth watching. If you're using Azure DevOps at all, then or GitHub, definitely watch that space. There's a lot of things being added and changed there. It's a pretty amazing to watch. Real quick, if you're curious how well Azure DevOps might scale, I like to show this slide. This is about a year old on the stats now. Microsoft has over 100,000 internal users. You can see, for example, they're doing nearly 5 million builds per month, over 12,000 employees contributing, and doing 82,000 deployments per day, more than we do in a year, let alone a day. I'm going to breeze through the pricing really fast. There's free options and then there's pay options. That's the version of pricing. 2 more slides. Check out the Azure DevOps Marketplace. There's all kinds of extensions in there, over 1,300 last time I checked, bringing cool features to the platform that aren't included out of the box. The demos I was using today were generated by this generator, so if you want to kick the tires in Azure DevOps but don't want to go through the hassle of building up a bunch of source code and work items and all that, go to this link and it'll do that for you automatically. And that is it. So thanks for listening, everybody, and we're ending exactly on time, even though I rushed there at the end. Please post questions in the chat window, and we'll get to those here in a while. Thank you.